important. Today we are going to study how to plot a velocity time graph for uniform acceleration. Uniform acceleration means acceleration or velocity increases or decreases by equal amounts by taking equal time intervals. Here you are given with the data. Two sets of values are given. This is the values of or different readings of velocity, and this is the time taken for it. So first reading is 0, 0, and velocity is given in meter per second and time is given in seconds. Second reading 9 meter per second velocity and 5 is the time taken. 18, 10, 27, 15, 36, 20, 45, 25 and 54, 30. So these are the different set of values given, that is for velocity and time. Okay, and from the data itself it is clear that this is an example. The data is showing a velocity time for a uniform acceleration. Here velocity increases by a rate of 9 meter per second. 9 plus 9 plus 9 plus 9 plus 9 plus 9, and time gap is also remains the same. 5 seconds is the time taken. So this is having, or we can say that this particular object is showing a uniform acceleration. Okay, and now we are going to see how we plot the graph between velocity and time. And first of all, the name of the graph is given velocity time graph, and down here we need to write what is the scale chosen on x-axis and y-axis. Okay, that I will write after setting the convenient scale on x-axis and y-axis. And as we did in the last class velocity time graph, same way we are going to write the set the time on x-axis and velocity on y-axis. And time values are 0, 5, 10. So this is 1 unit, 5 second. So time readings are plotted on the x-axis, and that is equal to the convenience scale set. So here 5, 10, 15, 20, 25, 30. And along y, the readings are 0, 9, 18, 27, 36. And your reading as such you can take as the scale, but that is quite difficult to find the value of each small division when we are taking 1 unit is equal to 9 meter per second along y-axis. So for make the calculation simple, or to find value of each small division, we can set the scale as 1 unit is equal to 10 meter per second on y-axis. So on x-axis 1 unit is equal to x-axis 1 unit is equal to 5 seconds, and on y-axis 1 unit is equal to 10 meter per second. This is the scale set or convenient scale set on x-axis and y-axis. And now you are ready with the two axis names and two convenient scale on x-axis and y-axis. And now we want to find the point of intersection of the values or reading given. 0, 0, 0, 0 is the origin of the graph. Then 9 on y-axis and 5 on x-axis and 9. This is the point, 9th line, 9 on y-axis and 5 on x. This is the point of intersection. Next reading 10 on x-axis and 18 on y-axis. 10 on x-axis and 18. 18 means 2 lines down to 20. That is 18. So this is the point of intersection at 10, 18. Then 15, 27. This is 15 on x-axis and 27 on y-axis. So this is the point of intersection. Then 20. Then 36. 36 means next line to the 6th line from 30. So that is 36. Then 25, 45. This is the point of intersection. And finally 30 and 54. I marked all the point of intersections, and I join all the point of intersection from top to the origin. So now I got a straight line. Okay, the straight line for uniform acceleration, the acceleration straight line. So this is the straight line which shows the uniform acceleration, or we can say that the velocity at every instant it is gone increasing by a fixed amount. So this is showing the uniform acceleration. And from the uniform this graph we can find what is the distance travelled by the object at any instant of time or between any two time interval. For that I want to take 2 points on the straight line. So my points are A and E. I am taking 2 points on the straight line or the shape of the graph, and from A I want to draw a perpendicular to the x-axis, mark here as B. Same way from the next point E, drop a perpendicular to the x-axis and mark that points as C. Again draw a perpendicular from this point, from this first point to the perpendicular drawn is C. Okay, and here we got two shapes. One is a triangle on the top, that is ADE is a small triangle on the top of the shape, and down we have a rectangle ABCD. So these are the two shapes we are getting down to the points A and D. So down to A and D, after drawing two perpendiculars we are getting, and after drawing a perpendicular from A to D, we are getting a triangle on the top and it is followed by a rectangle on the bottom. So two shapes are here, and we can easily find the distance travelled by the object from A to E, or from 15 to 25, time taken from 15 to 25, or by taking 10 seconds. What is the distance travelled by the object by taking this time interval, and this time interval is 10 seconds, or from A to B.